Well, once again, welcome to the EMI Creation Care webinar. Our topic today being energy efficiency and solar power. I know some of you are still joining us, but I just want to make a start. And for those of you who are joining us and are new to EMI, it's wonderful to have you with us here at EMI. We design and build projects that bring the hope of Christ to communities around the world. I'm Rob Quell. I'm a mechanical engineer and project manager from the UK, and I live here in Managua, working with the EMI Nicaragua office. Now, this is the second in our webinar series on Creation Care. David Wright, for those of you who joined us last time, will have seen he opened us up introducing the topic of Creation Care. Creation Care is the act of stewarding God's creation, and as designers, construction managers, surveyors, amongst other things, we feel a particular responsibility to design and build well. Our projects can impact the planet for generations, and we want to have a positive impact and not a negative one. God's word speaks to the wonder of his creation, and as we join in praising him for the works of his hand, it's right that we feel convicted to ensure that at the same time, what we're doing is not mistreating or abusing his creation through the works of our own hands, but we are instead seeking to bless and restore. And restoration is very much a driving theme here at EMI. We've always sought to design with efficient use of resources at the centre of what we do. And in the last few years, we've sought to be more intentional about how we do that with the development of a Creation Care Forum and a Creation Care Working Group globally. And through what we've been learning in that process, we're excited to be opening up some of that, sharing what we've been learning and what we're continuing to learn to a broader audience. And this is very much a live development for us. One topic that's central to many, if not most, of our projects is the responsible use of energy. It has a huge daily impact on our environment. And as I say, it's really key to a lot of the projects we work in. As a mechanical engineer, it's a topic I get excited about. So I'm really pleased today that we're talking about energy efficiency and solar energy, specifically in the East African context. And I'm delighted to be joined by our friends in Uganda, in the Uganda office, Kent Jones, who's an electrical engineer, Daniel Frost, who manages our research and development department, and Samuel Tendo, who is an electrical engineer and also in our fellowship program. I'm just going to kick us off with a short prayer, if that's okay, before we get started. Heavenly Father, we thank you for the wonder of your creation. We pray that you would help us as we think about how we can better steward, cultivate, and care for it. We thank you, Lord, for Kent, for Daniel, for Samuel, for the experiences that you've shared with them over these years. And we pray you would bless them as they bring those experiences and share them with us. In Jesus' name, we pray. Amen. Just to let you know, there will be time for questions at the end of the session today. Do please put those in the chat at any point during the session, and we'll pick that up at the end. But for now, Kent, over to you.
Thank you, Rob. I want to start with a verse. May the Lord give you increase, you and your children. May you be blessed of the Lord, maker of heaven and earth. The heavens are the heavens of the Lord, and the earth he has given to the sons of men. Two things I want to reflect on there. One is God is our creator. And we, as his image bearers, we too enjoy creating and we enjoy managing this earth, which this verse clearly says that he's given us to do just that, to manage. So I thought we reflect on this verse just to get started and create the right frame of reference. I want you to remember something. One number, 600 million. 600 million is the number of people in the continent of Africa who do not have access to electricity. That is a very large percentage of our population. Slide number 1 paints what I think you will see is a pretty encouraging story at first glance. These are some East African countries, and this graph basically illustrates the source of our electric energy. It is overwhelmingly hydro. You say hydro is good, and we agree. You'll also see in there that we have emerging geothermal and a few other energy sources. You can see solar, but it's still quite small, and a few other sources. But on first glance, your response may be kudos, good job, Africa. Second glance, you might come to the same conclusion. Here's a growth of where our energy sources are over time. This is the newest information that I could find. Again, we're growing that hydro. Now, hydro is inherently limited, but we've continued to grow, and most of our energy comes from hydroelectric, large dams on some very large rivers. And geothermal is really starting to catch a lot of people's attentions because we do have a lot of hot gases along some of the rift valleys that we have. So you say, good, presentation is over. Africa, you're doing a wonderful job. Keep up the good work. You just got to find a way to get it to the rest of the people, right? Well, not right. I'm sorry. I've got to tell you the rest of the story. We actually have three major issues with energy in Africa. Number one, all of our electricity is clean, most of it. Unfortunately, that's not our major source of energy in this country. Secondly, and I gave you a number, I told you to memorize it, 600 million. We simply don't have access to that little bit of electricity that we do have. So many of us in this continent will try to finish the day with the dim light of a little oil lamp, and it'll be pouring out smoke and creating pollutants inside people's homes as they finish their day in a dim light. And the power that we have is not really good power. Now, we still have some nice green, clean sources, and the things that we're looking at now as a continent really aggressively are solar and geothermal. More about the sources. I wish I could tell you that the biomass energy that we use is predominantly biodigesters, but they're not. We burn massive amounts of wood and charcoal. So much so that in our cities, we have right around me, I can smell the charcoal in the air, and someone's burning some trash because I can smell the plastics burning. We create a huge amount of smoke and pollutants from the things that we burn, and that is by far the predominant energy source and light source for cooking and other things around the home. Second, we use a lot of petroleum products. There are an estimated 700,000 small, we call them bodas, small motorcycles zipping around our streets. All of our transportation is by boda, by taxi, and we move products in diesel trucks. And then sadly, what looked like a good story is not such a good story, because electricity is only about 1.5% of the energy we consume. A little bit more on who has the power. It shouldn't be a big surprise to discover that most of the people in the rural areas don't have electricity, and we have a lot more electricity in our urban areas. That shouldn't be a surprise. There's a lot of talk about moving more and more electricity, but the cost per installation skyrockets as you try to move into rural areas, and with the problems we have with reliability, the cost of servicing that rural power is quite high. If you pay attention to the line that I've drawn through the middle of this graph, that represents 50% of the population. And you'll still see that most of us, if you look at the blue bars, that's the combination of the rural and urban population. Most of those blue bars are still under 50% in our area. So yes, we have a lot of people that still don't have electricity. Another big problem, and you'll hear about this quite frequently in a lot of what we do at EMI with respect to creation care and taking care of the created, God's creation, his people, is to address power quality issues. I lose power 2-3 times a week. I have a voltage monitor. It will trip out usually twice in the evening. Even though I lose power, it usually comes back relatively soon, maybe 2 or 3 hours. So I don't lose things in my refrigerator. And the last point I'm going to hold off on, because we want to tell you about something we're doing to document power quality issues. We all know that we have many, many power quality issues. These power quality issues destroy equipment. In the United States, the average person loses power a little less than 1 time a year. I think it's 8.8%, 0.8 days per year. Here, we don't measure it in tens or hundreds. We measure it in terms of thousands of outages. We literally have outages all the time. And those of you that are listening with electrical backgrounds, you know that phase reversal can rip apart motors, flicker and can destroy compressors. Under voltage will burn out equipment. Over voltage will cause insulation systems to break down. So our power quality is very destructive. And when we want to share a couple of examples of what we're doing, and we'll get into the details of that in just a minute. We focus a lot on solar, and you'll be hearing us talking about solar as we progress today. Why? Because we have plenty of solar energy. I'll show that in the next slide. Our power needs are really small. A campus, a school or an orphanage with 10 structures may only pull a maximum of 20 kilowatts, maybe a total of about 220, 250 kilowatt hours per day. We don't use much power, so we don't have to have huge arrays of solar panels to meet our power needs. We lose power frequently. I've already established that with you. We not only lose power, but we have poor power, and we can very effectively isolate people from power quality issues with solar. The fifth thing that I wanted to point out is solar continues to drop in price dramatically on the continent. I've been here, I'm going on my 3rd year. I have seen prices literally halve on solar panels and inverters. And it's the right thing for the environment. Solar is easy to deploy. You do not have to extend power lines way out into urban areas to give solar to some people. So there is a huge number of reasons why solar makes sense. I told you we have sun. We're on the equator, so 6 to 8 every day, 12 hours of sun, good quality sun. We don't have good data about the amount of sun we lose because of blockage of clouds and rain. That data is just not available in this region of the world. But needless to say, it's very, very easy to design a robust solar system. In addition to that, manufacturers have gotten really creative. So we usually offer off-grid solutions so that we can completely isolate our clients from all the nasty things on the utility power, and we can harvest energy even if that utility power is very, very poor. So there are a lot of products which greatly simplify the installation so that you don't have to be an engineer or even a qualified installer to bring your wires from your utility, your wires from your solar power plant, and some wires from a battery bank and connect your load. It has gotten to be very, very simple, which makes small scale solar off-grid deployment very, very easy to do. What we want to do, that's kind of the big picture. What we want to do is highlight two things in particular that as we talk about taking care of people and being responsible in our environment, creation care, we call it, we want to highlight two projects that one we've just completed and one we're in the process of working on in order to ensure that we serve our client ministries with good, clean power. So I'm going to turn it over to Dan. This is Dan Probst.
All right. Yeah, thanks for joining, everyone. My name is Daniel Probst. I'm in the Uganda office with Kent and Samuel. I manage our research and development department. The department's set up to look at different ways that we can deliver better value to our clients. And one exciting project is this power logger or power quality analyzer. This helps in a lot of fronts. A lot of it is trying to look at reducing costs to our clients, but there's also this creation care element that goes hand in hand with what this device would enable us to do as designers. So yeah, here's some pictures. This is of a prototype unit down in our fabrication workshop. The picture on the left is the logging device. In the middle, we've got it hooked up to our workshop meter. We're comparing it against a fluke meter there. And then, yeah, I just really want to shout out to a Canadian volunteer that's really the brainchild behind this device, Nathan Weed. And he's an electrical engineer, lived in the developing world for a while. Has been on multiple EMI project trips. And, there are off-the-shelf devices that do a lot of what this device would do, but they're $15,000, whereas this looks to be coming in the range around $500. And then this device is actually a lot better suited for developing world contexts. So yeah, just a big shout out to Nathan and also his company, the company that he works for in Canada. They're a mineral geophysical minerals exploration company, and they have graciously been funding the development of these boards. So yeah, just want to thank them for that. If we go to the next slide, Ken. Yeah, kind of a high level of what we're looking to do with this device. We will be recording data on the device itself, but what we would like to be able to do is send this out to a cloud database and then have people like Kent and Samuel, our EEs, being able to log on, see the data, download the data. We would eventually like this to produce automated reports. So kind of the three main things that we're trying to address with this is one, just gathering usage data. As Kent's talked about, power and people's usage behavior is very different in the developing world. And so even though as EMI, we've really scaled back our designs electrically, as far as distribution systems, knowing that people and ministries here use a lot less power. Our EEs here have been going back to past projects and finding that we're really still oversizing our distribution systems. So generators, transformers, all the distribution wiring. If we had better data to estimate usage behavior from at the beginning, it would allow us to really hone in on the electrical design. The second thing is quality. As Kent's mentioned, quality is pretty bad. Frequencies kind of all over the place, on, off, high voltage, low voltage. And so this device would be able to log those events, as well as potentially control, say if the power gets too far out of range, it'd be able to potentially shut off power so that it does not destroy equipment of the ministry. The third thing that we really see this being helpful in is gathering that time of day usage information, and this really gets into solar design. So when our electrical engineers, what they're generally doing right now is trying to get utility bills, how much diesel the ministry is running in a month, and what they're paying the utility in a month. And that's helpful, but it doesn't necessarily say when the ministry is using that energy. And so if we could know that, one, we could design our solar to minimize battery usage. And then our electrical engineers have also been coaching our ministry partners, talking to them about their usage behavior and recommending, hey, if you did this activity during the day, you could basically use your free solar energy. Or even if they're on utility power, advising them when they could use off-peak, lower cost power, things like that. And that kind of information you don't get from just monthly utility bills, whereas this device would allow us to see time of use. So yeah, those are kind of the three main activities, or three main benefits that we see from this device. As far as it relates to creation care, maybe if you could go back one slide, Ken. Yeah, there's, if we can minimize the amount of materials that we're using on our sites, in particular our distribution systems, that can have a big impact on, how much, if we're just looking at carbon, say. I mean, there's a lot more to it than that, but if we're over designing our electrical distribution systems, we're using more materials, and it takes a lot of energy to produce those materials. So Kent and Samuel will be talking about the GEM ministry later on in the presentation here, but as they've gone back and looked at our design and the actual usage that's happening there, it's looking like we're still quite oversized compared to what the ministry is using. So we've just got a lot of extra material in there that's not necessarily benefiting the client. And with this data, we could do better than that. The other thing is related to the quality. If the power is burning out equipment, that equipment is going to landfills. We're consuming more equipment to fill the gap. And so if we can see the quality, understand what's going on, try to protect and mitigate against those things, we can help these ministries in saving equipment. So Nathan, the volunteer that's helped on this, he he was involved in a hospital in West Africa, and they kept having problems with a well pump, pretty big, expensive well pump. And after a couple of weeks, it burnt out. And what they found out was that the utility had switched phases, so the pump was running backwards, but they had no idea that this was going on. We've seen the same thing in our fabrication workshop. Utilities change phases, I think 3 times at least, which reverses our 3-phase motors, and that creates a big, safety problem with our saws and different things like that. So, so as far as creation care, minimizing the amount of materials that we're using. If you go to the second slide, or the next slide, Ken. As I mentioned, if we can get a better understanding of time of use that the ministry is using power, that graph there kind of highlights that. This allows our electrical engineers to more efficiently size solar. If we're guessing or having to make best guesses, we have to get conservative, and that drives up the price, which sometimes means that the ministries just decide not to go with solar. They can't afford it. Or if we do end up with a fairly big battery bank, that's just, again, more materials that are being used in the system. And if we had this information, we could either change the design or work with the ministry in changing their behavior, their usage behavior. So, yeah, we just see a lot of potential here. It's still a work in progress. We would love to bring someone on staff that has more of a programming, computer science background to help kind of develop this data pipeline. So taking this information, not just having it on the device, but sending it to a cloud database, enabling our electrical engineers from their desks to pull up the information. So just making a shout out there. We are looking for an electrical engineer or a computer science type person. We'd love to have more volunteers, and even if someone's interested in coming on staff, we've got a lot of projects that we're trying to push into this data pipeline. So I think that's all I've got. Thank you.
Sorry, Sam,
Sam.
you want to just unmute yourself?
Sorry. My name is Samuel Tendo from the EMI Uganda office. I'm an electrical engineering fellow. So I'm going to take you through an application, a case study, and this is one of our ministry partners, the GEM Foundation. We've installed a huge solar system for them. And just to start about this foundation or ministry, they serve children with special needs, orphaned children, abandoned children, and their mission is that every child with special needs is a gem from the heart of God. Therefore, they rescue abandoned gem, restore their God-given value, restore every gem into their God-given destiny. So the GEM Foundation takes care of over about 60 orphaned children. And then when these mature, they put them into assisted living homes. So they continue taking care of them. And also recently they are planning to start a school for them. And if you can see in the background, there's that construction site. It's a special needs school being constructed at the GEM Foundation. And EMI is working on this project, and Kent and I and Daniel have got a chance to also have a hand in this. So it's really interesting, and also I'm going to share about how we've developed a solar solution for this ministry. So the problems that this ministry faced, which are now the opportunities, was before EMI came into designed for them a solar system, they used to spend a lot of money on buying fuel for their diesel generator, just like Kent has shared and Daniel, that we lose a lot of power frequently here in Uganda. So their fuel prices per year were about $4,300, and their utility bill per year was about 6,000 US dollars. And then their equipment repair and maintenance costs were about 1,600 US dollars per year, and that's only based on poor power quality, without mentioning mechanical failures and damages. If you can go to the next slide, Kent. So, what are some of the best ways to save on electricity? Because Creation Care, we aim at minimizing environmentally detrimental energy solutions. So the best way to save on cost and also care for creation is not to use electricity at all. And what you see here is a diaper dryer design that is currently being worked on by our R&D department. Daniel and the other R&D team in the Uganda office are working on this. And the GEM Foundation, as I shared earlier, they care for orphaned children. Most of these are below the age of 5, maybe 10 years. And they use a lot of diapers, reusable diapers. So with this new solar diaper dryer system, they are going to be able to wash and dry these diapers inside this unit. And this comes with advantages such as you don't have to lay the diapers under the sun, which is typical for a Ugandan or African setting to dry clothes under the sun. So with this system, you have them protected from UV damage, and also you have minimum electricity costs because this does not run on electricity. It's specifically designed to aerate and dry these diapers. If we can go to the next slide, Kent. The other solution we have is a solar water pumping system at the same ministry. So if you see there, that those are 2 water tanks that serve this ministry, and above the water tanks are 7 solar PV panels. And this is a very simple and cost-effective design because we have a water pump that runs on both DC power and AC power, with priority given to DC power. So what the system does is you have your water pumped throughout the day when you have the sun, and then your tanks get filled up, and as you use this water, you keep pumping and filling up your tanks, and then you have enough storage to take you through the night. So the system does not involve batteries, so we do not need to store energy for it. And for the electrical engineers on this meeting, you know that batteries are the most expensive component in a solar system. So energy storage is about 5 times more expensive than energy harvesting in a solar system. So if we can go to the next slide, please. Yeah, like Daniel shared earlier, is one of our efforts as the electrical engineers at EMI is to train our ministry partners, clients, on how to effectively use the solar systems that we designed for them. So Daniel mentioned that the power quality analyzer is aimed at observing how our ministry partners use their energy. And this very much impacts on the cost of the solar systems we designed for them. So if you look at the left side, the graph on the left-hand side, that is the energy usage profile of GEM Foundation. And that data was recorded before EMI trained this ministry on how to use their energy. So there are 2 curves on that graph. We have a yellow curve and we have a blue curve. The blue curve is their energy usage, and then the yellow curve is the solar production by the system that we installed at this ministry. So before, you will observe that their energy usage was about 8 kilowatt hours average throughout the day. And that means they had a distributed power demand. So what does this mean? They used to do laundry in the morning, laundry in the night, running washing machines, running dryers. Yeah. And they did not know that they had all this free and cost-effective energy throughout the day under the yellow curve. So what EMI did was to go speak to this ministry and tell them that, hey, you have to plan your energy consumption activities. So we advised them to do the energy or the power demanding activities throughout the day. And we gave them a time frame, which is from about 10 a.m. up to 4 p.m. in the evening, because in that time frame, you're harvesting a lot of energy. You store some, but you have enough that you can use on the go. So that's why you observe on the right-hand side on the graph, you see that their blue curve increases to about 11 kilowatt peak demand a day. So that way they are able to harvest energy and use it on the go. The other opportunity that comes with this is you do not need to store a lot of energy, because most of the energy you use it on the go. And then in the evening, you turn down all these machines, the dryers, the washing machines, and then you only need to store energy to run your security lights, which makes the most expensive component of a solar system, the battery system, very cheap, because you have minimal need of energy to store. And then on the far right, you will see a Fluke power logger that was installed at this ministry's power panel to generate these graphs for us to analyze their data. And what the power quality analyzer is going to benefit our ministries is it's going to offer the same solution, but at a cheaper cost. So each ministry partner who is interested will be able to get this service at a very much cheaper cost. And that's what our R&D department is all about, to improve quality, but at a cheaper cost. May we go to the next slide, please, Kent? So this is the schematic for the system we've installed at GEM. Foundation, it's a 33 kilowatt power capacity system with 43 kilowatt hour battery storage capacity. We have 72 power panels installed currently, and we have lead-acid batteries on this system. So the benefit is, ever since we installed this system, all the energy, all the money and the costs that used to go on diesel fuel to run the generator is now saved. So over 4,300 US dollars is saved, and this ministry can use this money to take care of their GEMs, run their medical bills, finance the running of the ministry in lieu of investing it in diesel fuel. As well, you also care for the creation, because you do not run diesel fuel, which pollutes the environment. And then the other is you save on the energy cost. So they used to pay about 6,000 US dollars on electricity, that's utility power. But right now, they spend just about 30 US dollars a year. So all this money goes back into the ministry, helps them to run their other daily needs, such as medical care for the GEMs. And then equipment repair is anticipated to drop to 1,200 US dollars from 1,600 US dollars. So that's a huge drop because the system now offers a clean, constant 230 volts alternating current. So even if the national utility fluctuates, even if the voltage from the national utility fluctuates, our system, the inverter system, offers a clean and constant 230 volts alternating current output. And then the machines are able to run smoothly, reliably, and cost effectively. May we go to the next slide, please? So this is the actual setup at this ministry. So on the left-hand side, you will see those are the 72 solar panels, 550 watts each. And on the right-hand side is the inverter system, the 36 lead-acid batteries, and the switch gear. And then in the picture, you can see is a gentleman called Joshua Quisenberry. He's the Director Operations, GEM Foundation. And that's me as an intern then, taking him through this system. Can we go to the next slide, please? Okay, so I'll invite Daniel to come in, please, here.
Dan, you're on. If you take yourself off mute.
Oh yeah, sorry. Sorry, the slide got moved to the end. I already talked about this a little bit, but yeah, we're looking for volunteers and even someone willing to come on staff to help with the electronics, the firmware development, the data pipeline programming. So just wanted to use this opportunity to highlight that. I think there's a link that's been put in the chat to that career opportunity. But even if you're able to volunteer, we'd be interested in that as well, remotely.
Well, Ken, Dan, Samuel, thank you so much for that. Really, really interesting, and really enjoyed that. If I may, just want to reflect on some of those points that you raised. Ken talking about the 600 million without access to electricity, and correcting maybe that misnomer that there's a clean grid, hydro grid, but actually how many is that getting to, and how much is actually fuel that is being burnt for lighting, for cooking, and other needs that isn't captured in that. It's just interesting. But also this point about it's not just clean energy, it's the quality of the energy and the impact of that low quality electricity affecting people in so many different ways. And Dan, you picked up on that more with the power quality analyzer and data logger, and trying to do something about the fact that our partner ministries equipment is failing, the cost of that, the impact of that, but also informing our designs so that they are better sized, that we can reduce the amount of materials that are going into our designs. That's really interesting, seeing the impact of reducing copper per kilo. And the financial impact on that, and making solar options and other options more affordable by doing that. I think that's a really interesting point. And Samuel, just inspiring, seeing how some of that learning has been applied to that specific example at GEM. The financial saving is just tremendous, and really exciting to think what that financial saving can lead to. But also, it's the reduction of that amount of diesel that's just coughing out into the atmosphere, and how we can we can celebrate that. And this is just one project where we're applying this across many others. I also found that really interesting, how we're encouraging our ministries to use their power at times to match when it's being generated in the solar. And that again is just really clever thinking that doesn't maybe come naturally to our partner ministries, who obviously focused on what they're focused on and not thinking about some of the technical stuff that you guys have been so focused in. So I thought that was excellent to see, and the creativity as well of things like the diaper dryer. I know we haven't built that one yet, have we? But we hope to see that at some point, or something similar, and just really interesting. Being from the UK, just translating that would be nappies, but a nappy dryer that doesn't doesn't sound as good as diaper jar, does it? So thanks for sharing on that, guys. Really enjoyed that. And also the plug, Dan, for electrical engineers. That's really important to say for anybody listening in who thinks that might be something they're interested in, volunteering, or maybe even joining staff, or might know somebody who might be interested. As Dan said, there is a link in the chat there for how you could get involved in that and show your interest. So I know we've had a few questions already. Just want to open that up, and maybe if I can just access some of these questions here. We had a couple to do with this interesting element of when we can increase. So Josh and Brian sort of chiming in together. Thanks, guys. When we are making energy use more easy or more cheap, there's often this rebound effect that people start using more energy. It's a tricky question. I don't know if you guys have already answered for this, but how can we in EMI plan for changes in clients likely increase in energy use? How do you approach that?
I'll tackle that one. We use very little energy. Africa across the board has already switched to LEDs. The lamps in my house are 5-watt and 7-watt LEDs, and some of us will put a whopping 10-watt outside sometimes. You add all that up, and you'll find out that my total outside lights are less than what one incandescent bulb used to be. That is a fraction of the amount of energy and environmental impact of having just the smallest of fires, if that's the alternative for light or for something like that. We very rarely cook with electricity here. Even those of us that don't burn wood and charcoal, we burn natural gas in our oven. So and air conditioning, you just don't see. It's very comfortable here in East Africa. So there's really not a danger of the energy usage skyrocketing. The biggest problem is there's not much revenue to be generated by the utility company in servicing an area. There's just no dollars to be made. For that reason, a lot of that's just going to be solar. Solar is very inexpensive. If you can get a small battery and a charge controller, and have 2 lamps, maybe 2 500-watt lamps, 5-watt lamps, and a phone charger, then your life changes dramatically. Those energy amounts, you wouldn't even move the needle in the Western world.
Thanks, Ken. Dan, Samuel, I don't know if you wanted to add anything to that. No worries if not. We've got a technical one here from Larry Bentley about how bad is voltage distortion harmonics. I don't know how you want to qualify that, but it did look great.
Please go ahead, Kent.
We don't worry so much about the distortion. And we don't have a lot of nonlinear loads. I say that now we're working on schools where they're putting in 80 computers at a time. But we're more concerned about the magnitude of the voltage. It gets really low, what you would call brownouts probably. And then when some of the systems are lightly loaded, it goes really high. It is not unusual for us to have a conversation with the ministry, and we'll say, hey, look, are you using equipment? Yeah, we replace a lot of chargers. Okay, we think we know why. Or our motors in our dryers, or our washing machines, they just don't last very long. The beauty of being able to have these tools is we kind of know what the answer is. But if we can measure it, whether or not it's high or low or flicker, You want to kill your refrigerator? Let your electricity flicker. It'll kill that compressor. Some of the solutions are quite simple. Just switch it off. Wait for the flicker to be over with and have it come on again in 3 minutes. Not everybody has to have a solar system. So the solutions vary. So we're not so much concerned about the distortion of the waveform. We're more concerned about the interruption of it and the magnitude of it.
Yeah, thanks, Ken. Moving on to solar, we've got Bob Brillo here has asked, where do you source the solar panels on projects, I guess, that you guys have been working on in particular? Where have you been sourcing, and what are the maintenance needs for them? Anyone like to pick that up?
Okay, Sam, you got to tackle one of these.
All right. Yeah. So we work with one of the vendors called Ital Power Solutions. Ital Trade, sorry. And he supplies us with Jinko solar panels. And there are a couple of many other solar vendors here in Uganda. So solar panels are easily easily supplied and easy to reach here in Uganda.
So there'd be Chinese manufactured panels, is that right?
Genco is. Now, the inverters come from all over the place. The good news is we qualify the product that we select. We'll go visit the vendor. We'll look at the track record of the equipment we purchased. For the most part, unless it's something really tiny, we'll make sure that we can get it serviced locally. There is good stock and good supply in the big cities like Kampala. So getting the product is not hard. Just making sure that we qualify the product and make sure we select the vendors carefully. That's a service that we can also supply our client ministries to guard them from what looks like an unbelievable deal.
Right. And in terms of maintenance regimes, how we train or instruct our partner ministries cleaning panels, what is there much to it? Is there fairly simple systems? Is that right?
Our clients will clean the panels. They have the manpower, and it's really easy if they see the power starting to go lower. Jim, the example that Samuel just gave you, he even knows how to change filters and clean filters, and he'll even open up his inverters and vacuum them out. Because we're doing construction on their site, we're creating just a very large quantity of dust. But maintenance is an issue. Maintenance is a big issue here because of the amount of dust.
Yeah, something Josh Wood's just referring to, how much of a problem is dust for the effectiveness of solar panel ministries. I guess the answer to it is regular cleaning.
They don't mind cleaning.
Yeah. Well, one thing on solar, one thing that people keep asking is, with the rare earth metals and other materials in the batteries, in the panels, difficult to recycle them. Are we just going from one unclean energy source to another in a way? And how do we treat that? I know one thing you're talking about is how you reduce the amount of batteries you need through good design. But how do you feel about that element of using solar?
We're banking on the fact that the PV manufacturers, we're taking them at their word on the 20-year life on the panels. There is no question that you have something to dispose of after that period of time. We're very excited about lithium batteries. We can now buy them for about the same price for kilowatt hours as lead acids. So we are rapidly going away from lead acids. And those lithium batteries, the verdict is still out. We hear 10 or 15-year life. We shall see. But it's not anything like the problems you had when the lead acid would only last 2 or 3 years.
Good to hear. Well, look forward to hearing more about that. And we've got lots of questions. I think we've only got time for one more. We will try and get back to the other ones online if we can later. But it's a good news one because Gary would just like to know the actual cost savings at GEM. Again, Sam, can you remind me how much? It's like $4,000 a year on diesel, amongst other things. Is that right?
Okay, so the cost savings are on diesel fuel, $4,300. And then on the national utility, $6,000. And then on equipment maintenance based on poor power quality, $1,200, which is a total of $11,500.
We had a payback period of less than 4 years on that installation. But if we were to do it today, since the materials are so much less, it would be significantly less than 3 years. Maybe closer to 2. I haven't recalculated for that ministry.
It's really encouraging to see, and it's good to know it's one of those occasions where doing the right thing can also help steward financial resources as well. So really encouraging, thousands of dollars helping our ministries to invest those in other things. And I have to say at this point, a big shout out to CDS Engineering in Montana that sponsored some solar panel installation on our office here in Nicaragua, which has been a huge blessing to us. And here in Nicaragua, the payback period is between 5 to 6 years. So if anyone wants to make a donation and is passionate about solar energy, it's a great way to see good returns and help the environment at the same time. But listen, that's all we've got time for today. Again, I want to say a huge thank you to Ken, Samuel, and Dan for sharing with us. If you want to find out more about EMI, again, if you're new to EMI, do feel free to reach out to us on the website. There is a subscription link that we will be putting in the chat if it's not there already. And if you want to join us next time, our next Creation Care webinar is on the topic of creation care in disaster relief and disaster response and disaster risk reduction. And that is on August the 25th. So look out for details on that. That'll be on our website, August the 25th. One final thing I should say, this backdrop you see here, this is Laguna de Apoyo, a beautiful part of Nicaragua. If you ever have the chance to visit the land of lakes and volcanoes, we would love to show you this place. And I love it. And it reminds me of the wonder of God's creation. On this webinar series, we'd love to have backdrops going forward that show the beauty of creation in different parts of the world. So if you've got a particular scene or photo that you've taken from your part of the world that you would like to share on the call, then do please send that through to EMI. You can send that to my email address, rob.quayle@emiworld.org, or you can reach out through the other channels that we've described. Once again, thanks for joining us.